My dear students, uh, last class we discussed about the instantaneous centers and a number of instantaneous centers for a mechanism. Such type of topics we discussed. Now we will discuss about the angular velocity ratio theorem. That is here. This is the instantaneous center method. We calculated the velocity. Now we are discussing the angular velocity ratio theorem. Okay. In the beginning classes, velocity diagram, graphical method we discussed. After that, instantaneous method now we are discussing. In this instantaneous center method also, that is angular velocities. If you want to find an angular velocity, at that time how we will calculate that one? By using this angular velocity theorem, we will calculate that angular velocity. That is here when the angular velocity of a link is known and it is required to find the angular velocity of another link, locate their common instantaneous center. That is here in our 4-bar mechanism. In yesterday's class also I taken this same type of example for identification of the instantaneous centers. That's why once again I drawn the same diagram, 4-bar mechanism. In this mechanism, if you want to find an angular velocity, that is which link angular velocities are required. Suppose actually already for this crank angular velocity they given. Now we have to find a third link and fourth link. Third link and fourth link. If you want to find the angular velocity of either third or fourth link, suppose I will take to find an angular velocity of the fourth link. Now here, in addition to this fourth link, I will take the one more known angular velocity link. What is that one more known angular velocity link? That is the second link is there. Second link. Here for the second and fourth link, which one is the common instantaneous center? If you observe this 2, 4, this instantaneous center 2, 4, it represents the instantaneous center of second and fourth link. Is it right? So it is the common instantaneous center is there. About this particular point, now we will calculate the unknown angular velocity of the fourth link with the help of the known angular velocity. That is how we will calculate. As per the relative velocity principle, we know that relative velocity v is equal to angular velocity into link length. Is it right? So here, now in this particular case, I will take link 2. Link 2 is one of the disk containing that is somewhat larger size, that disk containing one point, that is the 24 point. Now the disk is rotating about the A point only. Now this entire disk is rotating about the A point. If I want to find the relative velocity of the 24 point at 24 point, v24 is equal to, what is that one? Angular velocity of the second link into its distance. What is the distance? From the 24 to 12. That's why here I wrote the formula v24 is equal to angular velocity into 24 to 12 distance. That is the link length distance. Is it right? And another one, fourth link is there. Here, if I want to find the relative velocity, that is here in fourth link also I will take one large size of the link portion. Over the link portion I will take one small point as the 24 point. If I want to find the relative velocity of the 24 point with respect to this one, now v24 is equal to, what is that one once again for fourth link? That one is rotating about the D point. Now here, so what is the relative velocity? Relative velocity v4 is equal to its angular velocity into its distance or link length. That is that length of that particular portion is 24 to 14 distance. That's why here I wrote v24 is equal to omega 4 into distance between the 24 instantaneous center and 14 instantaneous center. So here finally, here I got the two relations. If I substitute or equate these two relations, if you substitute or equate the two equations, we will get omega 4 by omega 2 is equal to distance between the 24 to 12 and the distance between the 2, 4 to 1, 4. This is nothing but a angular velocity theorem. That is the angular velocity ratio theorem. Okay, what it says indirectly that angular velocity is inversely proportional to its distance. If you observe, angular velocity of the second link is inversely proportional to the distance between the second link point 1, 2 and 2, 4 instantaneous center. In the same manner, omega 4 is inversely proportional to 2, 4 distance between the 2, 4 and 1, 4 instantaneous centers. Is it right? That is the theorem is there. We have to remember this particular one also. That is, whenever we are solving the problems with the help of instantaneous center method, we have to remember basically some of the principles. That is, one thing is the relative velocity principle, and second one is the Kennedy theorem, and the third one is the this angular velocity theorem also. Okay, by using these three, we can construct the velocity diagram or we will identify the instantaneous center points. In addition to that, we will find the relative velocities, angular velocities also. Okay, my dear students, this is the theory topic regarding the instantaneous center. Now we will move to the next one. That is, we will solve some simple problems for easy understanding on instantaneous center method concept. Okay, I will take one small problem. Okay, now you try to observe this particular problem very carefully. First of all, I will read the problem. In a slider crank mechanism, the length of the crank and the connecting rod are 200 mm and 800 mm respectively. If you observe this particular diagram, this is the crank OA and AB is the connecting rod. Its distances are measured above. Okay, locate all the instantaneous centers of the mechanism for the position of the crank when it has turned 30 degrees from the inner dead center. That is actually here it is moving from inner dead center to the outer dead center. Suppose like a piston from IDC to inner dead center to the outer ODC. Okay. Okay. Now also find the velocity of the slider and angular velocity of the connecting rod if the crank rotates at 40 radian per second. That is a crank angular velocity they given indirectly. Okay. Now first of all, we have to find or locate the instantaneous centers at all positions. Okay, sorry, in this particular position, for the position. Okay, and now here in this diagram, first of all, here below I drawn the total diagram once again. First of all, here identify how many number of links are lies in our mechanism. One is the fixed link is there. Oh, is it right? This entire thing is the fixed link. Second one is the crank is there. Okay. Third one is the connecting rod is there. And fourth one is the slider. Is it right? Total how many number of links are there? 4. So, for identification of the instantaneous centers, now I drawn the basic diagram. I taken 4 number of points, corner points, and after that I construct the polygon. That is 1 to 2, 2 to 3, 3 to 4, 4 to 1. Directly I join. Next 2 to 4, there is no direct connection. Is it right? 1 to 3 also there is no. Actually, why I constructed this one means if I write links 1, 2, 3, 4, instantaneous centers are 1, 2, 1, 3, 1, 4. That is first link with the second link, first link with the third link, first link with the fourth link. Next second one with the third one, and second one with the fourth one. Next third one with the fourth one. Like that I drawn here. Total how many number of instantaneous centers are there? 6. I think you may write that formula. Number of instantaneous centers, capital N is equal to N into N minus 1 by 2. If you write that relation, we will get that number of instantaneous centers are the 6. Okay. Now, that 6 number of instantaneous centers are these. Now we have to identify these 6 number of instantaneous centers. Now I constructed that diagram. Now carefully listen. First of all, we have to identify by visual observation or inspection, we have to identify or locate the basic instantaneous centers. It may be a fixed instantaneous center or permanent instantaneous center. Okay. Now here suppose link 1 is the fixed one is there, 2 link 2 crank. These two are pivoted at this particular point. That's why I will take a one fixed instantaneous center 1 2. Is it okay? Next one. Link 1 is the fixed one is there. Link 4 is the sliding. Sliding means if you construct the velocity line, that line is perpendicular. Actually, here that is located at infinite distance. At infinite distance. In yesterday's class also I mentioned some of the basic points. So I indicate at 1 4 instantaneous center 1 4 is located at infinite distance. The same thing I wrote here also. Why you wrote here, sir? You may get some certain doubt. Link 1 is the fixed one. This fourth is the sliding one. It is having a horizontal motion. That's why here also I constructed 1 4. Okay. Along the same line, it is a horizontal motion is there. That's why at this particular point also I constructed. Okay. Next one is the 2 3. Link 2 and link 3. Link 2 and link 3. These two are pivoted at this particular point. This is the another instantaneous center. Okay. Now how many number of instantaneous centers we identify? So sorry, one more instantaneous center. Link 3 connecting rod is pivoted with the slider at this particular point. This is also definitely one of the permanent instantaneous center. Is it right? So this is another one. Total how many number of instantaneous centers we identified? 4 number of instantaneous centers. What are that 4? 1 2, 2 3, 3 4 and 1 4. Okay. Now that is what are the remaining 2 instantaneous centers? 2 4 and 1 3. These 2 instantaneous centers now we have to identify. These two are the neither fixed nor permanent instantaneous centers. Now we have to identify the 2 instantaneous centers. Suppose now I will join. That is what are that one? Suppose I want to I locate 1 3. So join one point with 3 to form a triangle. While I am forming a triangle, here 2 triangles are there. First of all, I will take one triangle. That is 1 4 3. 1 4 3. This is the hypotenuse is there. Next one is the 1 4 4 3. 2 links. That is where the 1 4 and 4 3 instantaneous centers. 1 4 and 4 3. 1 4 is here. This is the line 1 4 instantaneous center line at infinite distance. 3 4 is this one. So I extended this particular one with a dashed line. Next one is the another triangle is the 1 2 2 3. 1 2 instantaneous center is this one. 2 3 is this one. Next you extend that particular one. Why I constructed or extended this line? Do you observe that particular point, or on what basis I extended this one? Do you have any idea, my dear students? On what basis I extended this line? As per the Kennedy theorem, whenever the two bodies are having a relative motion with the fixed element, definitely the 3 instantaneous center must be lies on the same straight line. That's why I extended the 1 2 2 3 line. In the same manner, 1 4 3 4 instantaneous centers. Why? Because here 1 4 1 link, 3 4 1 link. That's why 1 4 and 3 4. One more link is the 1 3 is there. Definitely these 3 must be lies on the one straight line. In the same manner, 1 2 1 link and 2 3 1 link. This is the one instantaneous center and this is another instantaneous center. Next third one is the 1 3. Definitely that 1 3 must be lies on the same straight line as per the Kennedy theorem. So I extended this line. Is it right? So where these two lines are meet each other, I indicated that intersection point as the 1 3. Is it right? My dear students, do you observe my point? So like that we identified the 1 3 instantaneous center also. Next, here I required the 2 4 instantaneous center. So 2 4 this one. So join that 2 4. Why? Because second link is not directly connected to the fourth link. That's why you join with a dashed line. Okay. Second link is not directly connected to the fourth link. That's why you constructed the dashed line here. When I am constructing dashed line, here 2 triangles are formed. The 2 triangles are the 2, 1, 4, one triangle, and another one is the 2, 3, 4 triangle is there. Okay. Now once again, in 2, 1, 4 triangle, now you have to identify 1, 2 is the one link and 1, 4 is the one link. So 2, 4 is the another link. Definitely, as per the Kennedy's theorem, these three instantaneous centers, what are the three? 1, 2, 1, 4, 2, 4 must be lies on the same straight line. Hence, extend the 1, 2, 1, 4 instantaneous centers line. 1, 2 is the this one, 1, 4 is here, this particular line is there. That's why I extended these two instantaneous centers in one particular direction. You may extend downward or upward, I don't know initially. You may extend either upward or downward. Next, another triangle is the 2, 3, 4. That is the three links are there, two second link, third link and fourth link. As per the Kennedy theorem, its the instantaneous center must be lies on the same straight line. What are the 2, 3 instantaneous center and 3, 4 instantaneous center? This is the 2, 3 and this one is the 3, 4. So I extended this instantaneous joining of this instantaneous center points up to this one. Where this extension line meets the previous extension line, indicate that intersectional point as the 2, 4. That is the new instantaneous center 2, 4. Now we got the total 6 number of instantaneous centers. Try to identify 1, 2, 1, 2, 3. Second one, 1, 2 is the fixed instantaneous center, permanent instantaneous center. Next 3, 4 is the permanent instantaneous center. Here 1, 4 is the here. This is also a fixed instantaneous center. Okay. Now here next one is the 1, 4. Actually, this one is the permanent instantaneous, not the fixed one. And another one is the 2 more is the 2, 4 and 1, 3. Total 6 number of instantaneous centers we obtain. The first bit is over. The location of the instantaneous centers. Now second bit. What is the second bit? Also find the here. Also find the linear velocities. Also find the linear velocities. Okay. Suppose linear velocity. What are the linear velocity? Suppose linear velocity of the instantaneous center 2, 4 point. 2, 4 point. Linear velocity of the 2, 4 point. Just here they are asking also find the velocity of the slider. Okay. What is the slider? Actually fourth link is the slider. Okay. Fourth link is the slider. Now first of all we will calculate the velocity with respect to this particular one. So relative velocity V24 is equal to, how we will consider relative velocity V24 is equal to angular velocity of the second link omega 2 into its distance between the 2, 4 and 1, 2. Sir, how you write this particular relation? You may get certain doubt. We know that based on the relative velocity principle, V is equal to angular velocity into link length. In the previous concept also I explained, we know the angular velocity of the second link. We know the angular velocity of the second link, that is 40 radian per second. Now I will take this link as a one flat disk, this much area. On this particular area, here 2, 4 point is located. Now I want to find the angular velocity at this particular point. That's why V24 is equal to angular velocity of this link into its the distance of this particular one, 2, 4 to 1, 2 or 1, 2 to 2, 4. Okay, that's why here I forgotten one more important point. Please consider this particular point, my dear students. While you are constructing this diagram, don't construct the roughly. You have to take a one suitable scale, and as per the link length, you have to take a one suitable scale. If possible, you construct on the graph sheet. Otherwise, properly with the proper angles, you have to construct this particular one. If you do not follow the dimensions, we will not get the accurate values, or we are unable to find the velocities. Whatever the angle of the link, second link is there, I taken here 30 degrees. Whatever the link length 200 is there, you have to consider 200. Here 800 you have to consider. Like that only you have to construct this diagram, my dear students. If you do not follow the linked lens, this particular distance dimension becomes changes, your linear velocity becomes changes. That's why you have to construct with proper instruments. Protractor, scale, pencil, eraser, these things are very essential for this particular topic. Earlier graphical method also, there also with the help of these instruments only we have to construct the velocity diagram. Okay, remember this particular points, my dear students. Even external examination or internal examination also we have to carry all these particular instruments. Okay, don't ignore. Even if you know the concept, if you do not have these instruments, definitely your answer may be wrong answer. Okay, now that is here how much distance we obtain in this graph or in this diagram. Suppose if you construct properly, the distance is the 0.12. So if you multiply these two one, our relative velocity is the 4.92 meter per second. Okay, 24 point. That is, if I observe here, this slider, it is also having a one common instantaneous center, that is the 24 instantaneous center. Obviously, that is here. Obviously, this slider also will have the same relative velocity. That's why no need to calculate once again. So here, relative velocity or linear velocity of the slider is the 4.92 meter per second. Okay. Next, we will move to the another problem. Now, I taken the more number of links for your understanding purpose. Now, all of you must go through the some more problems in textbooks, solved problems or unsolved problems or previous examination paper problems. Now, I will read. First of all, I will read the problem. A mechanism as shown in figure. OA is a 200 mm, AB is the 1.5 meter, BC is the 600, and CD is the 500 mm, and B is 400 mm. Locate all the instantaneous centers. First, we have to locate all the instantaneous centers. If crank OA rotates uniformly at 120 rpm clockwise, find the velocity of BCD. Velocity of the BCD. Okay, these links. Next, angular velocity of the links AB, BC, CD. Angular velocity of this link, and this link. Okay, now they are asking this particular point. First of all, now observe here how many number of links are there? Fixed link, this one, and here and here. Here this fixed link, entire thing we will consider the one link. Next, OA crank is the second link. AB connecting rod is the third link. One more coupler type of one. Here, this one is the fourth link BC, and CD here. This is the another second connecting rod. Here, this is the fifth link. Slider is the sixth link. Total how many number of links are there? 6. As per the number of instantaneous centers relation, capital N is equal to small n into n minus 1 by 2, that is equal to, we got the, that is 15 number of instantaneous centers. How will get that 15 number of instantaneous centers? Now here actually write the link numbers and instantaneous center. First one with the second link, first one with the third link, first one with the fourth link, first one with the fifth link, first one with the sixth link, second one with the third link, second one with the fourth link, second one with the fifth link, second one with sixth link. In the same manner, third, fourth, fifth, and so on. Okay. Total observe here how many number of instantaneous centers are there? 15. 15 number of instantaneous centers. Now here, first of all, here you construct the polygon with the 6 number of links. Why? Because one link is connected to the another link. That's why you start from first link to the sixth link. You construct a one polygon. That is, first link is the fixed link, and second link is the crank is there. 1, 2, 3, 4, 5, 6. You take the 6 number of points, one particular polygon manner. and you construct a one polygon. 6 points means you will get a hexagon. 1 2 2 3 3 4 4 5 5 6. Is it right? 6 1. That is 1. This is 1. 2 second link is connected. 2 3 connected. 3 4 connected. 4 5 connected. 5 6 connected. And 6 1 is connected to the fixed one. That is the 6 1. And here you have to remember one more thing also. BC is the which link? BC is the fourth link. Fourth link is once again connected to the fixed one, pivoted point. That's why 1 4 also I constructed with a continuation line. Continuation line. Whatever the continuation lines I constructed, that instantaneous centers we can easily observe the, or we can easily get the by using the visual inspection. Okay. Now that is how many number of instantaneous centers? 1 2 2 3 3 4 1 2 2 3 3 4 4 5 5 6 6 1, next 1 4, and I think totally 7 number of instantaneous centers. Okay, the 7 number of instantaneous center by visual inspection we will get. Now observe here the 7 number of instantaneous centers. That is a 1 2, 1 instantaneous pivoted point. Next 2 3 pivoted point. 3 4 pivoted point. 4 5 pivoted point. 5 6 pivoted point. Next 6 1 or 1 6. It is a slider, that's why that one is located at infinite distance. So I drawn wherever the fixed points are there, through all that particular point I indicated that instantaneous center at infinite distance. 1 6. 6 number of instantaneous centers are over. One more, 7th one is the 1 4 is there. 1 4 means observe here. This is the pivoted point. This is the 7 instantaneous center. Now we have to find the remaining 8 number of instantaneous centers one by one very properly. Okay. Next, what instantaneous center? Now you want to find. 1 2 is over. 1 3 is it over? 1 3. 1 3 is it over? No. Not yet. So you join first point with the third one. First point with third one. While you are constructing first point with third one, try to observe, is there two triangles are formed or not? Yes. 1 2 3 is the one triangle, and 1 4 3 is the another triangle. Okay. Very good. 1 2 3 is the one triangle, and 1 4 3 is the another triangle. Now here, first of all 1 2 3, I will take 1 2 3 triangle. That is here, as per the Kennedy's theorem, link 1 2 3, 3 links are there. It's the 3 instantaneous centers must be placed on the same straight line. That is, what are the 3 instantaneous centers? 1 2 2 3 3 1 or 1 3 1 3. Is that right? So obtaining of 1 3, 1 2 2 3 must be placed on the same straight line. Extend that one. Here this is the 1 2 point, this is the 2 3 point. Extend this particular one in one particular direction. Next, and another one is the here 1 4 3, 1 4 and 3 4. 2 instantaneous centers are there. Here this is the 1 4 instantaneous center, and 3 4. I think 3 4 we got here. Is it right? 3 4. Extend these two lines. Where these two lines are meet each other, indicate that intersection point as a 1 3. Okay. So we have obtained 8th instantaneous center. Next one, 9th instantaneous center. Suppose I want to find the 1 4. 1 4 you got already, we identified 1 4. Sorry. Next 1 5. Shall we take 1 5? Okay, 1 5. Now you join 1 5 triangle, 1 5 points. It is not directly connected. That's why I used the dashed lines. You have to remember this particular point. Here also two triangles are there. 1 6 5 triangle, 1 4 5 triangle. Okay. Now we have to identify the 1 5 instantaneous center. That instantaneous center, one of the triangle is here, suppose 165. That is as per the Kennedy theorem, 1 6 instantaneous center and 5 6 instantaneous center and 1 5 instantaneous center must lie on the same straight line. We know the 1 6 and 5 6. Where the two located? Just observe here 1 6. This is this one and this one 1 6 5 6. That means here your extension line must be downward or upward here. Okay. Next, another triangle is the another side triangle is the 1 4 5, 1 4 point and 4 5 point, instantaneous center points. Extend 1 4 and 4 5. Extend these two lines. Extend these two lines. Where the two lines are meet each other, indicate that intersection point as the 1 5 instantaneous center. Okay, 1 5 instantaneous center. Okay. Next, this is the 9th one or 10th one? 9th one. 9th one. First 7 instantaneous centers we calculated. 1 3 is the 8th one. 1 5 is the 9th one. 9th instantaneous center. Next one is the 2 4. 2 4 we required. 2 3 already over. 2 4. 2 4. Join second point with the fourth one. Here two triangles are formed or not identified. 2 3 4 is the one triangle. Okay. Next triangle is the 1 2 4. 2 1 4. 2 1 4. 2 1 4 and 2 3 4. Suppose I will take 2 3 4. 2 3 4 means 2 3 instantaneous center, 3 4 instantaneous center. Where the 2 3 and 3 4 instantaneous centers? This is the 2 3 and 3 4 instantaneous centers. Okay, 2 3 3 4 instantaneous centers. Next one is the another side is the 2 1 1 4 instantaneous centers. 2 1 1 4. 2 1 means 1 2 1 4. Here this is the 1 2. This one is the 1 4. You join. Where these two lines, this particular intersection point is nothing but a 2 4. Is it right? I think 32 minutes are there. I explained up to 2 4. If required, the remaining points I will explain next class. Why? Because if too lengthy is there, uploading of my video it is a somewhat difficulty. That's why remaining points, if possible, I will explain next class. And otherwise, yourself you try to identify the remaining points. Okay, definitely I will explain. Now at present I will stop my class. And another thing is the how to go through the textbook also. Try to solve the some of the solved or unsolved problems. Thank you.